main engine fuel oil system. So basically from the service tank to main engine fuel oil system. So from the service tank we are taking the oil and passing it to a blender through fuel oil supply pump, and from the blender we are passing it to a main engine fuel oil auto filter, and from the auto filter the oil is passed to a viscosity controller through a fuel oil circulation pump. From the viscosity controller we are injecting it to the main engine. So yeah, this is all about fuel oil system. And regarding this main engine lube oil system, just remember we have three main engine lube oil system. One is the main engine lube oil system, then main engine turbocharger lube oil system, and finally this main engine cylinder oil lubrication system. We'll see individually in detail after this particular introduction. So just know these three things, okay? And regarding main engine jacket cooling water system, just remember the system behaves individually with respect to the situation. That is, while engine is running, it behaves differently. While engine is not running, it is going to behave differently. I mean, the operation is going to get differed. Let's see about that also in detail, but just get an idea of this as well. So yeah, I'll get into the detailed one right now. So I've made a short note about this. So to see in detail, I'll just share like in a flow chart. I mean like a flow diagram, where actually we take the oil, we bunker the oil, and we actually keep it in the settling tank, and from the settling tank we will transfer it to the service tank, and from the service tank it is actually getting passed to blender through a fuel oil supply pump, and from the blender the fuel oil will get to the auto filter, from where through the fuel oil circulation pump, before getting injected into the main engine, it will be passing through a viscosity controller. The viscosity controller actually regulates the heating of that particular oil, so that to maintain the viscosity, so on my shape, the fuel oil supply pump speed is actually regulated by a pressure transmitter that is fitted at the pump's discharge manifold, and moreover, the main thing is fuel oil circulation pump, that is this one, delivers the fuel oil actually more than actually is required by the engine, so that if surplus fuel is available at the injection line, and positive pressure is ensured, and so to make sure that they do that, moreover the viscosity is actually controlling the oil's viscosity by heating the oil, by controlling the steam, so that is how it's achieved. So on my shape we have set the viscosity meter to a set point of 12 CST. 12 CST generally maintains around 143 to 147 degrees Celsius, and CST is the unit of the viscosity, that is centistokes. And moreover, if you're going to ask where this fuel is getting actually supplied, or where it is actually injected in a main engine, means it is injected in main engine's fuel injection valve. Since my engine is an ME engine, electronic engine, so it is injected with the current timing and the amount. And moreover, the pump and motor ratings are over here regarding the circulation pump. So this is all about the main engine fuel oil system, okay? And while talking about the main engine lube oil system, as I told you in the short note, that we're having like three things: lube oil system with main engine lube oil system, main engine turbocharger lube oil system, and main engine cylinder oil lubrication system. Let's check in detail about the main engine lube oil system. So basically, from main engine system oil sump tank through a lube oil pump, it is passed to a lube oil cooler, and from the cooler it is getting passed through a filter, which is of 50 micron, and from this particular area it is getting to the main engine, and from the main engine again to the main engine system oil sump tank, that is lube oil main engine system's lube oil sump tank. Okay, basically you have to understand why a lube oil is required. It is just for lubrication purpose, and especially for main engine lube oil system, it is to lubricate the main bearing and piston cooling manifolds, and mostly as like a fuel oil, they maintain a viscosity. Even for main lube oil, a viscosity is to be maintained, especially mostly on my ship it is 45 degree, you know. And in this system we're gonna have an oil and water monitoring system, the capacity of the pump and the motor of my ship I have mentioned over here. Okay, similarly the second one, main engine turbocharger lube oil system. So basically how the flow works is from the main engine turbocharger lube oil tank through a lube oil pump, turbocharger lube oil pump, it is passed to a cooler, and through a cooler, I mean from a cooler it is passed through a filter of 25 micron, and from the filter it is getting passed to the main engine turbocharger, from the turbocharger again to the lube oil tank. In fuel oil what happens is actually the fuel is burnt, it is being consumed, but over here it is being used again and again. And in any oil system you're gonna have a cooler or filter because you need to filter it, so everywhere you will find this filter, you know. And basically turbocharger lube oil, why a turbocharger lube oil lubrication is required is because you need to lubricate the turbocharger bearings, you know, and the capacity in my shape of that particular pump is over here. And the third one is main engine cylinder oil lubrication system. So basically how the flow works over here is from the cylinder oil storage tank through a cylinder oil transfer pump, it is being transferred to a service tank, and from the service tank to the main engine through a heating unit that maintains at the 45 degree temperature. So why this is required is because to lubricate the pistons and cylinders of the main engine, you know, the alkalinity of cylinder oil should match the sulfur content of HFO so that the corrosive wear will get impacted, you know. So that is one of the reason why you have to maintain the alkalinity, you know, of a cylinder oil. So basically this is about the main engine lube oil system, nothing much. I just wanted to give you in a short so that you get in a basic idea, because rather than justly wondering what are all this, since it is related with marine engineering stuff, so just to give a basic idea. So this is how basically this all works. And regarding main jacket cooling water system, as I told you before, it is conditional. Based on the condition this jacket cooling water system works, like basically depending on like while the main engine is running how it is going to behave, while main engine is idle means like when the main engine is stopped, or when it is at port, when it is drifting, then main engine is running. So basically how the system works. So basically this is how from the freshwater tank the main engine jacket cooling water pump is going to suck that water and going to pass around the engine, and from around the engine it is again getting back to the pump, and around the engine, pump, engine, pump, engine. So this will become like a closed loop over here, you know. But this happens only when the outlet temperature from main engine is normal. Basically, as you know, why the jacket cooling water is required means is to cool the main engine. It is basically like a radiator in a car, like you need to cool the engine. Here also the ship's main engine needs cooling, so we use water to cool the engine around the engine. So that is what is this, and this water is taken from the freshwater expansion tank, and through the pump it is circulated around the main engine, and upon cooling the water is again getting circulated if suppose the water temperature is normal. Whereas upon cooling the engine, if the water is really hot, the water from the engine is going to get passed through an LT cooler, and from the LT cooler again to the pump to the engine, and when the water is high again to the LT cooler. That is why I mentioned if the outlet temperature is high, then this one. If the outlet temperature is normal, from the pump to main engine to the pump, main engine, pump. So this is how it's going to work. Whereas well, the main engine is idle, or as I said, when the engine is stopped, when it is drifting or something like that, so the water that we store in expansion tank through a preheater, it will get passed through the main engine jacket cooling water pump, from the pump to the engine to the pump. And we are using preheater because we cannot use a colder water. Also the water needs to be maintained at certain temperature, else the thermal stress on the main engine will occur, which is not actually good for the internal parts of the engine. So is of course the idea is to cool the engine, but you cannot always use a cold water. It's like a baby kept in an incubator. The water also should be maintained at certain temperature, at least of ambient temperature. So the ambient doesn't mean like if the ambient is cold, you have to use a cold water. I mean, like a warm water, but that's not that warm that will heat, or it will add more heat to the engine. In fact, the main idea is to remove the heat. So this is the thing. And the water that we're going to store in the expansion tank should be a fresh water that is added with the descaling chemical, because these waters are going to pass through the line, through the pipelines, so that the pipeline should not get, you know, scaled, or something blockages should occur in future. So we use this kind of thing. So yeah, a descaling chemical along with the fresh water will use the system. And why we are using jacket cooling water system is to cool the main engine. So this is all about that. Thank you.